2016 relative velocity. It's always question 2. Question 2b. A man can swim at 5/6 meters per second. He swims across a river 125 meters wide. The river has a constant speed of 25/18 meters per second. And how long will it take him if he swims to reach the opposite bank? First part here as quickly as possible. So we've two banks. I'll consider this the far bank. The river is flowing at 25/18. The man starts over here, let's say at this point here, and he wants to go as quickly as possible. So he just needs to, if we imagine he can go in this direction, like in a bath, it's completely still, he can go at 5/6 in the J direction. So it's 125 wide in the J direction. So my distance divided by my speed will give me my time. So 125 divided by 5/6 is equal to 150 seconds. That's if he just goes across as quickly as possible. Now as little downstream as possible. So what's going on here? So as little downstream as possible is straight across. If we imagine that he is here, he wants to end up, let's say, somewhere like this here. That's as little downstream as possible. Well, what has to happen for him to get there? Well, the river is flowing in that direction. So if he swims in this direction, it'll be hard for him to get back to this point where he wants to get across to. So if the river's going in that direction, he's going to, in some way, he's going to need to attempt or aim to go in this direction so that he's brought in this direction back to that point. So that's the velocity of the man. The man is going, even though he's going left to right, he's getting dragged left to right here. So this is his velocity, this line along here. This is the velocity of my man. This is the velocity of my river. And this is the velocity of the man relative to the river. And we can put an angle in here, A. Similar alternate angle up here, A, if we need it. So let's see what we can say with vectors here. The velocity of the river is equal to just 25/18 in the I direction. 25/18 I plus 0j. The velocity of the man we don't know. I should put or there, but we know that the velocity of the man, and we've done a lot of these questions, is the man relative to the river plus the velocity of the river. So if we write down the velocity of the man relative to the river with my angle here and my speed, I've got 5/6, and cos is adjacent here to A, so cos A in the I direction. I'll put my signs in now, and we have 5/6 sine A in the J direction, and my signs, if it's this direction up here or into this sector up here, it's into the negative positive sector. So it's negative positive. So let's write down the velocity of the man. In terms of these two vectors, we're going to get 25/18 minus 5/6 cos A. 25/18 minus 5/6 cos A in the I direction, and just 5/6 sine A in the J direction. So this question is dealing in time here, and we know that distance is equal to speed by time, and we have my velocity here, my VT. So my distance in these cases are my velocity in my I direction and my J direction by time. So we're looking for this distance in the I direction. So let's turn your phone off while recording. Let's use this just firstly, 25/18 in the I direction to see what we get, minus 5/6 cos A. Velocity by time is equal to distance. Okay, so we have a few unknowns there. And velocity 5/6 sine A by time is equal to distance, and we do have the distance in the J direction. It's 125 from the beginning of the question here, 125. So that's equal to 125. So 6 times 125 is 750. Divided by 5 is 150. So we're going to get time is equal to 150 over sine A. So if we fill this in here now, that does it say maximum as quickly and as little? We're dealing with max and min problems always in these questions. So if we can get to a point where we can differentiate and let our answer equal 0 with our max and min, we'll be able to get an answer here. And I think that's where this question goes. If we take this route with it, there are a few other routes we could use. We may look at them in another video. So let's look at 25 over 18 minus 5 over 6 cos A times time. The time taken to get there in terms of sine A is 150 over sine A. Okay, there's always a tendency to try and simplify too quickly here. But if we type 25 by 150 divided by 18 into a calculator, we're going to get 625 over 3. So that's going to give me 625 over 3 sine A for this one times this one. And then 5 by 150, that's again my 750 divided by 6 is 125, and we would have 125 on top, cos A minus 125 cos A over sine A. Now, to get the same denominators here, I'm going to multiply this right hand one by 1, 3 over 3, to get 3 sine A on the bottom. So we'll have a denominator of 3 sine A, and our numerator will be 625 minus 375, and the second one is cos A. So that's what this distance is here. Have we written it down? That's that distance. That's this distance along here. How far he has traveled in the I direction. We're going to keep it at a minimum. Actually, I might call it X because it's along the I direction here. Let's call it X. And I had called it D here, hadn't I? Doesn't really matter. I'll call it X. So we have this distance. If we want this distance when it's a minimum, we differentiate X with respect to my other variable, which is my angle. Because obviously if we change the angle, it will change where he lands. And before I do this, I'm just going to factor out here. There's a 125 in this one and this one. 5 times 125. And if I take the 125 out, it might make more sense. 125, and if I take the 3 out of the bottom, I can keep my constant outside and make it easier. So that's 125 over 3 times 5 minus 3 cos A on top. And on the bottom, I just have sine A. So I can differentiate this quotient real question. So if I differentiate the bottom, sine A goes to cos A. If you follow the differentiation rules, we'll write down what each of them are first. And if we differentiate cos A, cos goes to minus sine. So minus cos goes to plus sine. 5 goes to 0. So we're going to go from minus 3 cos A to plus 3 cos A. That's what the top, 3 sine A. That's what the top will become. So if we differentiate here, on the bottom, we're going to have the bottom squared. So we're going to have sine squared A on the bottom to be squared. I'll just leave a little bit of room for my constant. Actually, I'll put it in front. Just remind me to bring it back in if I need to. 125 over 3. I'm not going to need it here because I'm going to be letting one of them equal 0, but that's my constant in front here. So now we have the bottom, which is sine A, by the top differentiated, which is 3 sine A. So the bottom by the top differentiated, and then it's minus the top by the bottom differentiated. So the top, so we have minus 5 minus 3 cos A by the bottom differentiated, which I'm just about to rub out here, this cos A. And we will end up with 125 over 3 times 3 sine squared A for the first part. I can see I'm gonna have a minus 5 cos A. And then I'm gonna have a minus and a minus, these ones here, minus plus 3 cos squared A. On top and on the bottom, I'm gonna have sine squared A. And for this to be a minimum or a maximum, we're going to have to let this equal 0. So for this whole thing to be equal 0, the top of the fraction has to be equal to 0. So we can say that 3 by sine squared A plus cos squared A minus 5 cos A is equal to 0. 3 minus 5 cos A is equal to 0. So we're going to get cos A to be 3 over 5, giving me sine A to be, well, we have our h on the bottom 5, so it has to be the 4 over 5. And if we go back up to our time was in terms of sine A, didn't we say that time was 150 divided by 4 over 5 is equal to 150 by 5 over 4. So you're multiplying 150 by 1.25. So you're adding a quarter, which is 37.5187.5 seconds is the time here for this I direction to be a minimum or to get directly across.